Okay, let's look at the homework 5.2, 5.3, number 8. Right? So we have this function f of x, 2x times quantity x minus 3 cubed. Right, first, let's see, the domain is, right, since this is a polynomial function, domain is all real numbers. So we'll just write it as, let's see, parentheses, negative infinity to positive infinity, right? So let's look at that, right? Got that, right? So we want to find what is the y-intercept, right? So in order to find the y-intercept, we set x equal to 0. So let's do that, right? So y-intercept is y-intercept, right? So we're gonna set x equals 0. F of 0 is equal to, right? This one's easy. 2 times 0, 0 times anything is 0, so it's going to be 0. Right? So let's go back. Right? Y-intercept is 0. Right? Check that. Right? Got that. Alright, next, x-intercepts. Let's find the x-intercepts. Right? So if you want to find x-intercepts, we're going to set y equal to 0. Right? So let's do that. So we're going to set y equal to 0. Right? Which means that we're going to set the whole function equal to 0. So you have a 2x times x minus 3 cubed is equal to 0, right? Which is going to give us, right here, x equals 0, right? If we set x minus 3 equal to 0, so x equals 3, right? So 0 and 3. So let's go back and type it in. Right, so it's 0, comma, 3. Right, so let's check that. I got it. Right, what is the local extrema? Local max, and let's say we're looking for a local max. All right, so let's do that. All right, so in order to find a local max, we're gonna take the derivative to find the critical numbers. So f prime of x is equal to, right, so 2 is just a constant multiple, so I put it here, right? Then I'm gonna use product rule. So first guy is x, second guy is quantity x minus 3 cubed, right? Derivative of the first guy is 1, right, times second guy is x minus 3 cubed plus, right, first guy is x times derivative of quantity x minus 3 cubed would be, put 3 in front, keep the quantity x minus 3, subtract 1 from the power, so it's 2, right? Then multiply by derivative inside, which happens to be 1, so it doesn't really do anything, times 1. Right? Alright, multiply by 1 really doesn't do anything, so I'm going to just scratch it out. Alright, scratch that out. Alright, then look for a common factor. Right? So there is 2, so we still have 2. Right? Then you have quantity x minus 3. You have 3 of them in the first term. You have 2 of them in the second term, so we can take out 2 of them. So x minus 3 squared. So we factor this guy out. And I'm going to circle just 3 to indicate that there's another x minus 3 there. All right, I think that's all. So I'm gonna just collect the leftover. All right, leftover term is x minus 3 from there. So you have x minus 3, right? And the leftover term from the second term would be 3x. So it's going to be plus 3x, right? And to clean up a little bit, you're going to get 2 and the quantity x minus 3 squared, right? So combine x and the 3x, so you will get 4x, right? Then you have minus 3, right? So set that equal to 0 to find the critical numbers. Right, critical numbers would be, let's see, so it's going to be x equals, right, from here, setting x minus 3 equal to 0, so 3 is one of them, right, setting 4x minus 3 equal to 0, so you're going to get 3 quarters, right, so those are critical numbers. Right, so we want to find local max, so we're going to do a number line. All right, x. So I'm going to put 2 tick marks for 3 and 3 over 4. Okay, so right, 3/4 is a smaller, so we'll put it on the left, and 3 is a larger number, so we'll put it on the right. All right, then we're going to look at the sign of f prime. All right, so anything smaller than 3/4, so I'll try x equals 0. Right, so if you plug in 0, so this is actually, you can see that 2 is positive, and because of the square, this is always positive, so we don't have to worry about that. So we just have to worry about this. So it's 0 minus 3, so it's negative. Right, so positive times negative is going to be negative. Right, so any number between 3/4 and 3, so I like 1, so I'll try 1. Right, so these guys are always positive, but if you put 1, 4 minus 3 is positive, right? So you have a positive here. Right, any number bigger than 3, so try 4. Right, so this is positive, and this is going to be positive too, so it's going to be all positive again. All right, so you can see that the function, original function, is decreasing here, then the increasing, and gets flat and increasing again, right? Which means that you're going to have a local min here, but this is going to be neither. So maybe I should write that. So you're going to have a local minimum here, and here, since it's increasing, this is going to be neither. Right? So we do not have a local maximum. So maybe we're gonna, right? So local, there is no local maximum, right? Then check the answer. Right, got that. All right, so local minimum. So we already found the local minimum. So let's go back. All right, local minimum is at x equals 3/4. So we're gonna have to find the corresponding y value. So we're gonna plug in 3/4 into the function. So that's going to be 2 times 3/4. All right, so you have 3/4 minus 3, right? Minus 3. 3, same thing as 12/4. All right, then you have to cube that. All right, so you're going to have, let's say 2 and the 4 cancel out, so you're going to have 2. So this is going to be 3/2 times, right? So it's going to be, this is going to be definitely negative. So 3 minus 12 is negative 9 over 4. Alright, so this is going to be, let's see, the bottom number is very, oh sorry, you have to cube that. Right, so it's going to be negative, right, so that we know. Right, you have 2, 4 cubed is going to be, 4 times 4 is 16. 16 times 4 is, 4 times 6 is 24, and 4 times 1 is 4, so 64. Then you have, so that's 64 times 2, so 128. Alright, so it's going to be 9, it's 9 cubed, it's going to be, 9 squared is 81 times 9. So it's going to be 9 and 72. Right, so 729. And then times 3, so you have to multiply by 3 again. Right, so 3 times 9 is 27. Right, 3 times 2 is 6, so it's 8. And 3 times 7 is 21. Right, so it's 2,187 over 128. All right, so it's a kind of a big number, but let's plug it in. All right, so local minimum is at 3/4. So I didn't have to find the corresponding value, but that's all right. So 3 over 4. All right, let's check the answer. All right, got that. All right, what are the inflection points? Okay, so we have to find the second derivative. So inflection point at, so we just need an x value. All right, so we have that. Then we have to take another derivative. So there's no room, so I'm gonna just erase what we have. All right, so we need to keep this guy right there. So I'm gonna just erase this. All right, so our first derivative we found was, so I'm gonna write that down, 2x minus 3 squared, and then you have a 4x minus 3. All right, so we're gonna take the derivative again. Oops. All right. All right, so another derivative. So f double prime of x is equal to, right, so 2 is there. Right, again we're going to use a product rule. So this is our first guy and this is our second guy. Right, derivative of the first guy, you have 2 quantity x minus 3 to the first power times derivative inside is going to be 1. So I'm not going to write that, and times the second, which is 4x minus 3 plus first guy is quantity x minus 3 squared times, right, derivative of the second, which is going to be 4. Right, so try to factor out the common factor. So there's 2 right there. And also, okay, 4 is 2 times 2, right? So we can factor out that 2 also. So 2 times 2 would be 4. So 4 is factored out, right? Then also x minus 3 here, and there are 2 of them. So factor x minus 3, right? And what's left is, right, 4x minus 3, right? And you're going to have, there's a 2 times x, so it's 2x, right? And 2 times negative 3 is negative 6. Right? So clean that up. you're going to get 4 x minus 3 times quantity. So this is going to be, let's see, 4x and a 2x, so that's 6x, right, minus, you have negative 3 and a negative 6, so it's going to be a 9. So you can actually pull out the 3, so I'm going to make that 12. Alright, so pull out 3, so it's going to be 2x minus 3. Alright, then we're going to do the number line to see we have a concavity change. Alright, so you have 2 tick marks. Alright, actually we have to set that equal to 0. Alright, so that will give us x equals, easy one, 3. This one is going to give you 3 halves. Alright, so you're going to have 3 halves here and 3 here. Alright, then we look at the sign of the second derivative. Alright, so anything smaller than 3 halves, I'm going to try 0. Alright, so 0, so that's going to be negative, and put 0, that's going to be negative. 12 is a positive. Alright, so you can see that it's positive. Right, which means that you're going to have a concave up shape, upward. Alright, so between 3 halves and the 3, so we can try x equals 2. Alright, so plug in 2, so that's going to be negative right here. And but if you put 2 here, 4 minus 3, so that will be positive. So positive times negative times positive is negative. Right, then we can try x equals 4. Right, then you can see that 4 minus 3 is positive. Right, 2 times 4 is 8, minus 3 is positive, so every one is positive. So you have a positive sign here, so which means that you have a concave downward here, and you have a concave upward here. Alright, so we have a concavity change. So we know that there's going to be an inflection point at 3/4, inflection point. And also at x equals 3, there's an inflection point. Alright, so let's go back and type it in. Alright, so inflection points is at 3 halves and at 3. Alright, check the answer. Alright, got that. Alright, on what interval is f is increasing and decreasing? Alright, so we have to go back to the derivative. Okay, so we're back then. This was the number line we did for the first derivative. So first derivative is negative on the interval from negative infinity to 3/4. And after that, it's positive, so it's increasing. So let's answer that question. Alright, so it's increasing. F is increasing on interval from 3/4 to infinity. And decreasing on negative infinity to 3/4. Right. Then, all right. So let's check the answer. All right, got that. On what interval is concave up and concave down? All right. So we have to look at the number line for the second derivative. All right. So this was the number line. So it's concave up on negative infinity to 3 halves, and after that, after 3, and between 3 halves and 3 is concave down. Alright, so let's type it in. Alright, it's concave upward on negative infinity to 3 halves. And let's see, answer in interval note. Use a okay, you have to use a comma to separate them. Oops. All right, so comma, and 3 to positive infinity. All right, and the concave down in between, so it's going to be 3/2 and 3. All right, so let's check that. All right, got that. All right, so sketch the graph of y equals f of x. All right, so we're going to look at the concavity and increasing and decreasing. All right, so this is a number line for the first derivative and second derivative. It's kind of hard to see in two separate ones, so I'm going to combine these two. So I'm going to say, I'm going to do one number line. All right, so for the first derivative, so up here, all right, so we know that, let's see, 3, you need to have that, so that's a critical number. So I'll put the divider there. And also a 3/4. So 3/4 is probably over here. Actually, yeah, 3/4 right here. So those are critical numbers, all right? And we know that since, let's see, first derivative is negative, which means that it's decreasing here. All right, maybe draw a picture like this. All right, so maybe I'll do that, decreasing here. All right, between here positive, so it's increasing here, and a positive, so increasing again. All right, so it's a decreasing, increasing, and increasing again. All right, then concavity wise, so it's 3 is one place, another place is inflection point is at 3/2. All right, so you have a concave down shape, so it's a second derivative, tells you that it's going to be concave up on this interval. Between 3/2 and 3, it's concave down, and after 3, it's concave up. All right, so that's that. So we can see that the graph is going to be, it's going to look like this. So it's going to go down, decrease and concave up, and increase in concave, so increase in the concave up, right? Then decrease, increase in concave down, and increase in the concave up, right? So that's the ballpark shape. So let's see if that's good enough. So go to the choices, right? So decreasing and increasing and increasing. So none of these guys have that. So this is it. So A. Right? Check the answer. Right? Got that. All right. That's it. I hope that this was clear.